Hello everyone, welcome to my presentation. I'm Jiezhang from UCL, and today I'm going to talk about automatic testing and improvement of machine translation. So translations are very important for people to communicate from different countries using different languages. But the problems in translations can be quite serious. For example, in history, the human mistranslations once led to war. And for machine translations like Google Translate, actually they have more problems. So here are two machine translation disasters that have happened in China. So you can see that in the first photo is a Chinese menu, and the roasted gluten is translated into roasted husband, which is pretty scary. In the second photo, it's a warning to warn people to watch your step, but the English translation is sleep and fall down carefully. So there are more problems. Sometimes the machine translations can be quite unfair. So here are some real examples that I found in Google Translate in July last year. So when I translate men do good research in computer science into Chinese, so when it's men, good is translated into very good. But when it's women, good is translated into a lot. And the same thing happens for male students and female students. Certainly, very good and a lot are totally different. So I have to admit that as a female researcher, these translation problems are kind of hurt, no matter whether the problems come from training data or not. So we call these translation problems inconsistency bugs. And I'm pretty sure that most of you should be very familiar with this kind of bugs if you often read news or tweets from the American president. Okay, so how should we handle these translation bugs? Traditionally, people use human oracle, which are human translations, to find the translation problems. And people will debug the training data to do bug localization because usually many problems come from the training data. And people will do model retraining to try to improve the overall translation quality, with more training data and better learning algorithms. But these traditional methods, they are very expensive due to the human oracle and the model retraining process. And also, it is not online, it's not real time. Just imagine that a real user is now using the machine translation, but some translation is buggy. There's no way that these traditional methods, they give the testing results and give real-time fix for this real user. And the real user will have to use the buggy translation. And also, it is not bug specific, because when you retrain a model, you get a new model and with totally new behaviors. So some bugs are fixed, but new bugs may appear. And many well-formed translations might be affected. So to tackle these challenges in this paper, we propose automatic testing and repair method for machine translation. And this method does not need bug localization. It is cheap, fast, real-time, and flexible. So how did we do this? So we want to do testing, we need test inputs. And here we use mutation, which we will replace a word with its context similar word. And we will then use filtering to filter those low quality test inputs. We also need a test oracle to find the bug. So here we use metamorphic correlation, which the idea is that we hope the translations of the unmutated parts should remain similar. And we use consistency metrics to measure the similarity. Once the similarity is below some threshold, we could say that we detect a bug. After detecting bugs, we use gray box or black box repair to try to fix the bugs in a post-process manner. Because the test input generation and oracle generation, they are quite straightforward and simple. So due to time limit, I will just skip these two steps and go directly into the repair part. So once we have detected a bug, there is inconsistency, right? But which one is correct? Without human beings, we don't know. What if neither of them is correct? So to try to automatically find the solution, the answer to this, we generate more mutants and get the translations for each mutant. And we then try to get answers from these mutant translations. So we do a ranking of all these translations based on the predicted probability, or we do a cross-reference among these translations to trying to find a translation that has the largest similarity with other translations, of course, on the unchanged parts. And after we have chosen the best translation, we will combine this translation with the original translation, and also we will combine the changed word, do a word mapping. So in this way, we map back and change the original translation based on the mutant translation to get the final repaired translation. So in this whole process, we don't need source code, we don't need the learning algorithm. And all we need is the translation output, which we could call this a black box, or we just need the translation predictability, which we call this a gray box repair. So for the evaluation part, we choose the most widely used industrial machine translator, Google Translate, and also the most popular academia machine translator, which is called Transformer, as our evaluation subjects. So remember that our approach has 3 steps. So we just design a research question for each step. So next, I'm going to quickly go through our results due to time limit. For the first research question, we would like to know whether the test inputs are good enough. So the manual inspection indicates that we have a test input accuracy of 99%, which means most of our generated test inputs, they're quite natural. And for the second research question, we would like to know whether the approach is able to detect bugs. So we found that we have an F measure of 0.82 for the Google Translate and 0.88 for Transformer. And whether we use the consistency matrix or manual inspection, the results reveal that Google Translate has about 36% inconsistent translations on the test inputs that we generated. And finally, we would like to know whether our approach is able to repair the bugs. So we found that black box repair reduces on average almost 30% bugs for Google Translate and almost 20% bugs for Transformer. So gray box, because we don't have the predictability for Google Translate, so we only evaluate on Transformer, and we found that gray box repairs average 30% bugs for Transformer. So for the efficiency, we also would like to know whether our approach is fast enough to provide real-time feedback for users. So we found that the average test time is shorter than 1 second, and the average repair time is shorter than 3 seconds. Okay, so to conclude, we introduce a black box and a gray box automatic repair method for machine translation. It requires neither the source code nor the training data. It is automatic, cheap, real-time, and fast, and also very flexible because it enables the repair of a specific bug without touching other well-formed translations. Okay, that's all. Thank you very much for your time. And please feel free to contact me if you have any questions or comments or suggestions. And so this is my email, and I really look forward to having more discussions with you on machine translation and also other related topics. Thank you very much. Take care. Bye.